Good morning. Today we'll be looking at plasmolysis, hemolysis, turgidity, and flaccidity. In our previous video, we were able to look at osmosis and diffusion. That I made it clear to you that diffusion is the movement of molecule from the region of higher concentration to lower concentration until it is evenly distributed. They will now make reference to the case of osmosis being the process whereby molecules, majorly liquid, move from the region of lower concentration to higher concentration through a selective permeable membrane. That is what case of osmosis. Now today we'll be looking at plasmolysis, hemolysis, turgidity, and flaccidity. But in order to iron out these two, there are three conditions which a solution can exist that I need to make it clear to you. Now we have hypotonic, and we now have isotonic. Now for the case of hyper, as the name implies, it means higher concentration. Then tonic means concentration, then hyper means high. Then hypo here, as the name implies, it means lower concentration. Then as the name implies here, iso means same concentration. Now it means for hyper, it means a solution that have a higher concentration. For instance, sugar solution or salt solution is said to be hypertonic. Then hypotonic might be just a salt solution with lesser concentration. That is, the amount of the salt dissolved inside the water is minimal compared to in the case of hyper. Then iso is just like a normal concentration, that is no salt or sugar level that is concentration is at normal, that is neutral precisely, or may I say that it is deionized, is on normal concentration. Now plasmolysis, what's it known to be? Plasmolysis is the shrinkage away of the cytoplasm of a cell when being placed in a solution with higher concentration, which is hypertonic solution. Now that word shrinkage away, it means that when a cell is placed inside a solution that is of higher concentration, what will happen? The cytoplasm of the cell will shrink. What leads to the shrinking? Due to loss of water. The conch of the cell is of lower concentration, while the water where it's found is of higher concentration. Then what will happen? Content from the cytoplasm will be lost into the solution known as hypertonic. By so doing, the cytoplasm of this cell will end up becoming shrinked. Typical example of these two cells drawn here now. This is Hydra Cell. This is a normal Hydra Cell living in an isotonic condition. While this is a Hydra Cell living in hypertonic solution. In this case now, you can see that the cell of this organism, that is the cytoplasm, shrinked compared to this, meaning that it has lost water into the solution. Now another case is known as hemolysis. Hemolysis, I will use this diagram to explain both hemolysis and turgidity. Hemolysis is like a reverse case of plasmolysis, but it's totally different. In the sense that plasmolysis majorly occur in plants, but hemolysis majorly occur in animal. But in animal, major part of animal where it occur is the red blood cell. The red blood cell or the red blood corpuscle or the erythrocyte. That is where hemolysis occur. Why this occur in plants precisely. Now, in this case of hemolysis now, it is when the cell is now placed in hypotonic solution. That is a solution with normal concentration or of lower concentration, I mean. The concentration is lower. Now, if I drop a cell, red blood cell precisely, inside water with lower salt or sugar, what will happen? The salt we lost out its water into the cell, because the cell, which is the red blood cell, is of higher concentration. Now, being of higher concentration, what will happen? It will absorb the molecule of the solution and increase in size. When it has absorbed the molecule of the water and increase in size, we say, or become overstretched, we say it's said to be turgid. That defines what we call turgidity. That is to say that turgidity is a process whereby a cell absorb water and increase in size, or whereby a cell absorb water and become stretched. But mind you, turgidity is found in both plant and animal. Turgidity is majorly found in what? In plant. In animal now, as we are looking at as case study here, that is in the red blood cell, the red blood cell will first become turgid. That is, absorb a lot of water and swell or become overstretched. Then at the end of the day, when there is what? Continuous absorption of water due to higher concentration of the red blood cell, what will happen? The cell will burst. So meaning that what? Hemolysis is the process. From the name, hemo means red blood. Lysis means what? Splitting. That is, when the red blood cell absorb water and split, we call it what? Hemolysis. Then turgidity, like I said, is when a cell absorb water and increase in size without bursting. That is what we call what? Turgidity. Like I said earlier on, turgidity can be found in both plant and animal. Turgidity is a good example to plant in the sense that it enables plants to stand erect. At the same time, enable the stem of the plant, the leaf of the plant, the guide cell of the plant to be able to stand erect. You understand? That is, it provides support to what? To plant. Then the last case is flaccidity. What is flaccidity? Flaccidity is a process whereby plant precisely loses water more than it can absorb or more than it can hold. By so doing, we say that the cell is said to be what? Flaccid. The cell is said to be flaccid. Now, that's the summary of these four concepts. That is plasmolysis, hemolysis, turgidity, and flaccidity. Like if I may add,